time is much more flexible than we thought prior to the 20th century, say. And that all began with Einstein putting space and time together and coming up with this thing that we now call space-time. And a lot of modern discussion about time machines is really trying to exploit that flexibility.
Well, it's a funny thing that time is everywhere around us. We all experience it, and we put it to good use. We know what it means to say, I'm going to meet you at a certain time. We know what it means to say, this TV show takes an hour from start to finish. But when we get into the details, when we start asking ourselves, what does it really mean? What is time, and how should we think about it? It becomes complicated.
I mean, everybody has sort of an experience of time. We have memories of the past, we have no memories of the future, and so the experience of time is very much a one-directional thing.
When you take a cup of coffee and you pour a little teaspoonful of milk into your coffee, it mixes, and it will never unmix. You can't undo that. This is something that can happen forward in time, going from unmixed to mixed, but it never happens the other way. Certain things happen in one direction of time, but don't happen in the other direction.
Essentially, before Einstein, there used to be this idea that time was somehow absolute and disconnected. There was some idea of universal time, that everybody measured time in the same way no matter where they were located.
The old Newtonian idea is that time is universal. You go to a store in Switzerland and buy a perfect clock and synchronize it with another perfect clock, and they'd stay synchronized forever. And that's just wrong.
If you're moving through space, then you're relative to somebody else, then your measurement of time differs.
If you move those clocks relative to each other, time can change its pace, run slowly compared to the other clock, etc.
We can get to the future faster, if you like, by moving really quickly through space. We always travel to the future. One of the things about time is that you are traveling through it. You are always traveling into the future 1 minute per minute. The difference, though, in Einstein's universe is that to different people, the amount of time that is a minute will be different. A minute to me is different sitting here stationary than a minute is to someone zooming by at a rocket ship close to the speed of light.
So, for example, take an example. I get on a spacecraft and I fly to Alpha Centauri, the nearest star outside the sun, and that if I travel at 99.9999% of the speed of light, I come back. For you, that will have taken 8 years. For me and everything on that spacecraft, it will have taken about 4 days. So if you're traveling very close to the speed of light, the time between fixed events that we both agree on will be different.
So Einstein's great lesson is that time is kind of like space. And what that means is if you travel through time, you can experience different durations of time, just like if you walk through space, you can experience different distances. So if we imagine this is a region of space, and I say, I want to get to here from there. Well, clearly, if I said, how far do you have to travel to get from this point to that point, the answer would depend on the path you took. You could take a straight line, the shortest distance, but you could also take some curvy trajectory. You start at the same point, you end at the same point, but the distance you travel is different. This is not surprising to anyone. No one seems baffled by this fact. Now let's do exactly the same thing, except this is now, instead of space, instead of a piece of paper, this is the universe. So this direction here is time. And so instead of going from one point in space to another point in space, we go from one event, from one point in space and moment in time, to another event in the future. Well, again, you could travel in a straight line, which basically means I'm not moving. I'm sitting here in the room, time is flowing around me. But I could hop in my rocket ship and move out and go around in some crazy path through both space and time and come back and meet the person who stayed behind. And what Einstein teaches us is that the time elapsed on the wristwatch of the person who was traveling backwards and forwards will always read less time elapsed than the person who stayed behind. It's exactly like through space, you always travel further if you move around. Through time, Einstein says, you always experience less time by moving around. And you experience no time whatsoever if you move out at the speed of light and then come back at exactly the speed of light. That's the special role played by the speed of light in relativity.
Gravity is another thing that can change time. Time moves slowly, deeper in a gravitational field than it does in space.
The closer you are to a strongly gravitating object, the way to which time moves will depend on your proximity to that object.
When we see the Earth going around the sun, what Isaac Newton would have said is there's a force due to gravity pulling the Earth, preventing it from moving on a straight line. What Einstein says is that actually the Earth is moving on the straightest line it can possibly move on, but the point is that the space-time through which it travels is curved. There are no perfectly straight lines. Like if you try to draw a straight line on a curved surface, you just can't do it. You can sort of draw as straight a line as you possibly can. So we're here down on Earth, we think that everything is normal. We think that clocks move correctly, our hearts beat correctly, and so forth. But if we compare a clock here on Earth to a clock that is in orbit around the Earth, the clock in orbit feels less gravity. So compared to our clock down here, it ticks faster. Again, if we were in orbit, we wouldn't experience anything different because us and our clock and our heartbeat would all be up there in orbit. But if you try to compare what's going on, for example, in a GPS satellite, in a satellite that is zooming around the Earth, helping us find directions here on Earth, we need to correct for the fact that the clocks in the satellite are clicking at a different rate than the clocks here on our cars. If we were to bring them back, we would see the two clocks synchronized. They would be ticking at the same rate. But if we started them at the same time, moved one into space, and then brought it back, the one that was in space will have moved ahead of us just a little bit.
The idea of space-time is one that suggests that if you sort of step back from everything and look, you have a landscape of events. And that's really what space-time is. It's a landscape of events. And those events stretch off into the future and into the past. And a classical notion then of space-time is that it just is there for all time, because it includes time. And it's just a matter of connecting up these events where you can.
Time is another way to locate things in the universe, but it locates when things happen rather than where things happen. So Einstein's insight, one of his many insights, was that in fact space and time aren't that different. They're two different aspects of one thing called space-time. And if you start talking not only about what time something is happening here in this room, but also what time it is a million light years away in another galaxy, it becomes impossible to say once and for all that two things are happening at the same time. According to Einstein, it depends on the observer.
Time is this important, remarkable thing that, jokingly you could say, stops everything from happening at once. But it's something much more fundamental. It has a direction to it, etc. And it's still an open question as to exactly why does time have the properties it has. And that has something to do with our own perception of how events are organized in space-time. And so understanding that better is also key to understanding what can and can't you do with time machines if you could make them.